Hello student, in today's class we are going to discuss mixture and alligation theory. Okay, next. So, first we see the indexes of mixture and alligation. So, introduction to mixture and alligation. Then we see mixture and mean prices. Then we see some concept of mixture and alligation, concept 2, concept 3, and then summarize about today's lecture. Clear? So there is a disclaimer. The images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owner of these images. If you are the owner of any of the images used in this deck and have any concern or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. Now start our mixture and alligation. So first, what is mixture and alligation? Mixture and alligation are important concepts in mathematics, particularly in the field of ratio and proportion. These techniques are often used to solve problems related to combination of different substances or quantities, whether they be liquid, solid, or even populations. So, what is mixture? Mixture refers to the combination of two or more substances in such a way that they retain their individual properties. For instance, when different type of solutions or material are mixed, their result composition can be analyzed to determine the overall characteristics of the mixture, such as concentration or cost. So what is alligation? Alligation is a method used specifically for finding the ratio in which two or more ingredients at different prices or concentration must be mixed to obtain a mixture at a desired price or concentration. It simplifies the process of calculating the proportions of different components, making it easier to solve the problem that involve blending various items. Now, some see the mixture based things. So what is mixture? When two or more than two substances are mixed in any ratio to produce a product is known as mixture. For example, a mixture contains milk and water in ratio 4:1. If 10 liter of water is added to the mixture, the ratio becomes 2:1. Find the initial quantity of the mixture. Clear? Initial quantity of milk in the mixture. So we can know that, we can understand that ratio of the milk and water in the mixture is 4:1. So we can let initial quantity of milk is 4x and water is 1. So we can write it. Clear? Now, what will be the ratio become when 10 liter of water is added? So if this is the ratio of milk and water, so we can make the ratio. So 4x upon x and mixing 10 liter of water, adding, so x plus 10. So ratio become 2:1. So we can compare it. When we compare it, cross multiplying, so become 4x equals to 2 into x plus 10. So when we calculate it, we get the value of x, which is 10 liter. Clear? So question asked is, what is the initial quantity of milk? So initial quantity was 4x. So we get the value of x. We just put this value. We get 40 liter. So initial quantity of milk in the mixture is 40 liter. Next one. A mixture contains alcohol and water in ratio 3:2. If 10 liter of water is added to the mixture, the ratio becomes 1:1. Find the initial quantity of alcohol in the mixture. So first again we let 3:2 was the initial ratio of alcohol and water in the mixture. So we can let it 3x is alcohol and 2x is water. So now according to problem, we can write it 3x upon 2x plus 10 equals to 1:1 because it is given that when we add 10 liter of water, then it becomes 1:1. So this is our alcohol and this is our water. Water was previously 2x. When we add 10 liters, so it will become 2x plus 10. So the ratio will be equals to 1:1. So cross multiplying, then we get the value of our x. So x is 10 liter. So question says that find the initial quantity of alcohol in the mixture. So in initial quantity is 3x. So we just put the value and we get that, which is 30 liter. Clear? Now see some other examples. A mixture contains 40 liter of milk and water in ratio 7:3. How much water should be added to make the ratio 3:2? Clear? So initial quantity of milk and water are, so ratio is given 7:3. and quantity is given, which is 40 liter. So this 10 unit is always equals to 40, and milk is 7 unit. So milk will become 7 by 10 into 40. So it is 28 liter. In the same way, water will be 3 by 10 multiplying by 40, which is 12 liter. So let X liter of water to be added to make the ratio 3:2. Because previous ratio was 7:3, and when we add some water, the ratio becomes 3:2. So we can write it 28 upon 12 plus X, because only water has been added. So ratio becomes 3:2. Cross multiplying, we get the value of X. So when we calculate it, we get the value of X, which is 6.67 liter. So approximately 6.7 liter of water should be added. Clear? So what is mean price? The cost price of a unit quantity of mixture is called the mean price. Clear? The cost price of a unit quantity of mixture is called mean price. Now, alligation rules. Let the cost price of a unit of a cheaper article is rupees C, and that of a unit of costly article is D, and the average price or mean price of the mixture is M. Then we can write it quantity of cheaper article upon quantity of costly article is equals to cost price of a unit of costly article minus mean price. Same way upon mean price minus cost price of a unit of a cheaper article. Clear? So we can write it in this formation, mixture alligation. Cheaper, cost price of cheaper, cost price of dearer, dearer means costly. So, and there will be a mean price. So we can write it, because dearer will be more than mean price and cheaper will be less than mean price. So we can write it D minus M ratio, we get D minus M ratio, M minus C. And this will be the quantity ratio of cheaper and costlier article. Clear? Hence, we can write it quantity of cheaper upon quantity of dearer. We can write it in the formation of D minus M ratio, M minus C, or we can say that D minus M upon M minus C. Alligation. Alligation rule is also used to find the ratio in which two or more ingredients at their respective prices should be mixed to produce a mixture at a given price. For example, in what ratio must at rupees 14 rupees per kg be mixed with a tea rupees 18 rupees per kg, so that the mixture be worth rupees 17 rupees. Clear? So there is a two mixture of teas, 14 rupees, 18 rupees, and their mean average is given is 17 rupees. So we use the formula price of the cheaper, price of the dearer, and the mean price. So we get the ratio. So ratio will become 1:3. So when we calculate it, we get 18 minus 17. So it will become 1. 17 minus 14. So it will become 3. So quantity of cheaper upon quantity of dearer will become 18 minus 17 upon 17 minus 14, 1:3. Clear? Next. In what ratio must rice at rupees 30 rupee per kg be mixed with the rice at rupees 40 rupees per kg, so that the mixture be worth rupees 35 rupees per kg? Clear? So we know that the CP of 1 kg cheaper rice is 30 rupees, and we also know that the 1 kg dearer rice is 40 rupees per kg, and the mean price, average price is also known that 1 kg, which is 35. So formula is CP of dearer minus CP of mixture upon CP of cost price of mixture minus cost price of cheaper. Clear? So when we put the values 40 minus 35 upon 35 minus 30, because the cost price of dearer, it means costlier. Dearer means costlier. So it becomes 5:5 upon 5. So the ratio will become 1:1. So the required ratio will be 1:1. It means if we mix 1 kg of 30 rupees per kg rice and 1 kg of 40 rupees per kg rice, then the cost price of this mixture will become 35 rupees per kg. Clear? Next one. In what ratio must rice at rupees 25 rupees per kg be mixed with the rice at rupees 45 rupees per kg, so that the mixture be worth rupees 30 rupees per kg? Clear? So the CP of 1 kg cheaper rice is 25 rupees. It is given in the question. And CP of 1 kg dearer rice, we can say that costlier rice, which is also given 45 rupees. And we know that the the mixture price is worth, average prices should be 30 rupees per kg. So we again use the formula. Formula is CP of dearer minus cost of mixture, cost price of mixture upon cost of mixture minus CP of cheaper. So we just put these values. 45 minus 30 upon 30 minus 25. So ratio becomes 15/5, which is 3:1. So the required ratio is 3:1. Clear? Now see some second concept. And a container has milk and water in ratio 1:B. A second container of same capacity as first has milk and water in ratio C/D. Clear? So if both the mixture are emptied into third container, then the ratio of milk to water in third container is given by A upon A plus B plus C upon C plus D ratio B upon A plus B plus D upon C plus D. Clear? So see first example. There are two containers of equal capacity. The ratio of milk to water in the first container is 3:1. In the second container is 5:2. If they are mixed up, then the ratio of milk and water in the mixture will be clear. So according to formula, part of milk in first container will become 3/3 plus 1, which is 3/4. Same way, part of water in first container. So there are 3:1 in first container. So 1/3 plus 1, which is 1/4. Same way, part of milk in second container will become 5/5 plus 2, which is 5/7. Part of water in second container, which is 2. So 2/5 plus 2 will become 2/7. So what will be the required ratio? Required ratio will become 3/4 plus 5/7 ratio 1/4 plus 2/7. So when we calculate it, we get 41/28 ratio 15/28. So 28 cancel out. We get the ratio 41:15. Clear? Now next example is, there are two containers of equal capacity. The ratio of juice to water in the first container is 4:1. And in the second container, it is 3:2. If they are mixed together, what will be the ratio of juice to water in the mixture? Clear? Now we use the formula. Part of juice in first container, it will be 4/4 plus 1, because the ratio in first container is 4:1. So juice is 4 out of 5 total quantity. Same way, part of water in the first container, it is 1. So 1/4 plus 1, which is 1/5. Same way, part of juice in second container, ratio is 3:2. So it again become total 5. So 3/3 plus 2, which is 5, 3:5. 3/5, we can say that. And same way, what will be the water? Water will also 2/3 plus 2, which is 2/5. So need to find the ratio of juice and water. So what is the juice? Total amount of juice in the mixture will become 4/5 plus 3/5. So we get 7/5. Same way, what is the total amount of water in the mixture? 1/5. It is given. And we calculated 2/5 also given. When we add it, we get 3/5. So required ratio will become 7/5 upon 3/5. So when we calculate it, 5 cancel out. So we get 7:3 is the correct answer. Clear? Next one. There are two containers of equal capacity. The ratio of alcohol to water in first container is 7:3. And in the second container, it is 5:4. If they are mixed together, what will be the ratio of alcohol to water in the mixture? Now we use the formula. So part of alcohol in the first container, it becomes 7/7 plus 3, because total, if we take it, sum up the ratio, it will become 10 unit, and 7 unit is alcohol. So we can say that alcohol in first container is 7/10. Clear? So what will be the water? Water will be 3/10. 3/7 plus 3, which is 3/10. Same way, part of alcohol in second container. So ratio is 5:4. Total become 9. So in total of 9 unit, 5 unit is alcohol. So we can write it 5/9. Same way, what is the water in second container? So 4/9. 4/4 plus 5 is equals to 4/9. We can say that. So the total amount of alcohol in the mixture will become 7 by 10, clear, plus 5 by 9. So when we calculate it, 7 by 10 plus 5 by 9, it will become 63 upon 90, clear. And we say that plus 50 upon 90, because when we take the LCM, it will become 90. So we can write it 63 upon 90 plus 50 upon 90, which is 113 upon 90, clear. Same way, the total amount of water in the mixture, 10 and 9, LCM will be 90. So 27 upon 90 plus 40 upon 90. So it will become 67 upon 90. So the ratio will become, so the required ratio of alcohol and water in the mixture will become 113 upon 90 upon 67 upon 90. So 90 cancel out. It will become 113 upon 67. So we can say that the ratio of alcohol and water is 113 ratio 67. Now concept 3. Suppose a container contains X unit of a liquid from which Y unit are taken out and replaced by water. After an operation, quantity of pure liquid is X in the bracket 1 minus Y upon X to the power N. Clear? So, first we take the example related to this formula, where X is the initial concentration or initial quantity, we can say that. Y is the quantity taken out, and is number of terms, which is the repetition we applied in this process. Okay, so our first question is, a container contains 40 liter of milk. From this container, 4 liter of milk was taken out and replaced by water. This process was repeated further 2 times. How much milk is now contained by the container? Clear? So see the solution. Now we can say that amount of milk left after 3 operations, because total 3 operations has been going on. First time we took 4 liter of milk and we repeat this process 2 more times. So total 3 operations has been taken. Now we use the formula. Total amount is 40 liter. 1 minus Y is 4 liter. 4 upon 40. N is equals to 3 times, so power 3 liter. So when we calculate it, we get 40 multiplying by 9 by 10 into 9 by 10 into 9 by 10. Clear? So when we calculate it, we get the amount of milk in the container, which is 29.16 liter after 3 operations. Clear? Next one. A container contains 50 liter of juice. From this container, 5 liter of juice is taken out and replaced by water. This process is repeated 2 more times. How much juice is now left in the container? Clear? Now see the solution. We use this formula X. So X is above 50 liter because initial juice is 50 liter, initial quantity. 1 minus quantity taken out. How much quantity taken out? Which is 5 liter. So 5 upon initial quantity X and to the power 3, because 2 more times this process repeated. So total repetition will be 3 times. So when we calculate it, we get 51 minus 1 by 10 cube, which becomes 50 into 9 by 10 whole cube. So when we calculate it, we get 50 into 729 upon 1000. So it will become 36.45 liters. So the amount of juice left in the container is 36.45 liters. Clear? Now see other example. A container contains 100 liter of milk. From this container, 10 liter of milk is taken out and replaced by the water. This process is repeated 2 more times. How much milk is now left in the container? So again we use the formula. Initial quantity 1 minus quantity taken out upon initial quantity to the power n, which is representing the process of the repetition. Clear? So the amount of milk left after 3 operation, because this operation happens 3 times. So 100 in the bracket 1 minus 10 upon 100 power 3. So 0 cancel out. So it will become 100 1 minus 1 by 10 cube equals to 100 9 by 10 cube. So when we calculate it, we get 100 into 729 upon 1000. So when you calculate it, you get 72.9 liter of milk in the container left. Okay. Now summarizing our today's lecture. So mixture. Definition is combining two or more substances to form a new mixture. The formula becomes the average concentration or cost of mixture can be calculated by using average concentration equals to A represent the quantity into Ca plus B into Cb, concentration of quantity B upon A plus B, where A and B represent the quantity of the substance and C and Cb their respective concentration or cost. Clear? Same way, alligation purpose is used to find the average price or concentration when mixing different items to determine the ratio in which they should be mixed. So the alligation alternate, what we can use, finds the mixing ratio based on the difference between individual values and the averages. So we use the formula ratio equals to concentration of A minus average concentration upon average concentration minus concentration of B, where A and B represent the quantity of the substances and C and Cb are their respective concentration or cost. Okay. Now thank you.